to find this. It's 1, 2, 3, 4, 5, 6, 7, 8. It's 1, 2, 3, 4, 5, 6, 7, 8. So that means from negative 3 to positive 5, that is 8 units. Therefore, the length of AC will be equal to 8 units. AC will be equal to 8 units. Remember that if you are to find the distance, it's a matter of finding the difference between 2 points. A distance, it's a difference between 2 points. It's a difference between 2 points. So you can either write this as AC equals X at C minus X at A. AC is equal to X at C minus X at A. X at C is equal to 5 minus X at A is negative 3. Negative by negative, it's positive, therefore it will be 5 plus 3, which gives us 8 units. It gives us 8 units. So the length of AC would be equal to 8 units without using a distance formula. The length of AC is 8 units. Right, let's move to the next question, which says calculate the length of EF. The length of EF, which means we need to have this point for us to find the length here. And here, this line here, this line is perpendicular to the x-axis. There is 90 there, which means EF is parallel to the y-axis. This is a vertical line, which part can I use? Let's see this part here. It's fine. We will rewrite the questions. It's f at x equals x cubed minus 4x squared minus 11x plus 30. So we are to find the coordinates of point E. This is a stationary point or turning point. For turning point, you will have to derive. We derive. This will be, the gradient will be 3x squared minus 8x. When you multiply 2 by 4, it's 8x minus 11. That's our gradient. And then we let the gradient to be 0 because we are talking about the stationary point. The gradient at the turning point is 0. Therefore, we are to let the gradient to be 0. Our gradient will be equal to 0. And then the next step, you factorize. We factorize. That's equal to 0. And then we are going to have it's 8x minus that So this will be 11 and 1. Let's check. 11 minus 3, that is 8. So we need a negative value on our middle term. So it's negative here, and this will be plus 1. Therefore, 3x minus 11 is 0, and then x plus 1 is 0. We solve here. 3x equals 11. Here, x will be equal to negative 1. We divide here. X will be equal to 11 over 3. It's negative 1 and 11 over 3. Let's check if our values are correct. Remember that turning point must have a negative x value. This is on the fourth quadrant, therefore it has to have a positive x value. Therefore, we've got 11 here over 3. Up there, we've got negative 1. And then let's find y. For y value at the stationary point, we substitute the x value into the original equation. Therefore, we are to find f at 11 over 3. F at 11 over 3 will be equal to 11 over 3 cube minus, we are substituting here, it's minus 11 minus 11 over 3 minus 11 times 11 over 3 plus 30, and then let's find the remainder. The remainder will be negative 1 over 2. So which means our y value, it's negative since it's a fourth quadrant. That will be negative 400 over 27. We are not being asked of anything related to that, but then let us find the y value up there. Let's find f at negative 1. It's negative 1 cube minus 4 times negative 1 squared minus 11 times negative 1 plus 30. This will give us 36. This will give us 36. Therefore, the coordinates of G are negative 1 is to 36. Coordinates of point E are 11 over 3 is to negative 400 over 27. So we've got 36 here. Y is 36. Right, we are being asked to find the length of EF. The length of EF, remember, this is a vertical line. So you are to just count from this point to that point. That point to that point. Remember that y is 0 there. Here, y is negative 400 over 27. It's a matter of writing this as in units. From negative 400 over 27 to 0. That means our EF will be, let's write this in decimal, it will be 14.8. So that's the length of EF. It's a matter of checking here. It's a vertical line. So we just move from negative 400 over 27 to that point. Then our answer will be like that. But the most important thing here is that point E is our stationary point. So you are to find the length of that vertical line to 0. Let's move to the next question. Right, the next question was to find the gradient of a tangent at point B. The gradient of a tangent at point B. Remember, the gradient is a derivative. Point B is on the graph of F, so it's a gradient of a tangent to that point. We first derive our gradient. It's 8x minus 11. That's our gradient. But then now we are to find the gradient of a tangent at a given point. The gradient at a given point. So we substitute by the value of x. The gradient where x is equal to 2. It's 3 times 2 squared minus 8 times 2 minus 11. Therefore, the gradient will be negative 15. The gradient of a tangent at point B. You derive. For the gradient, you derive. But you are being given the point, so you take that x value and substitute it into your gradient to find the gradient of a tangent at that point. And then the next question.
A line with the gradient equal to negative 11 is a tangent to the curve F. Equal to negative 11. And the question determine the x coordinate of the point of contact. Points of contact.
We are to find the x coordinate here. We are to find the x coordinates of the points of contact. Right. This is the gradient of a tangent to this function. So we are to find the x coordinate. In other words, you are being given now the gradient of a tangent to this function. The gradient of a tangent is negative 11. This is a line with a gradient equals negative 11. Right, let's see. We've got the gradient of a tangent to this graph, which is that one. Our gradient of a tangent to the function of f is given by 3x squared minus 8x minus 11. And then you are being given that the gradient of this line to the function of f is negative 11. Therefore, you equate this to negative 11. 3x squared minus 8x minus 11 is equal to negative 11. So when you transpose that, this is 3x squared minus 8x equals negative 11 plus 11. We are left with 3x squared minus 8x equals 0. And then now we are to solve for x here. You just take out our common factor, which is x into 3x minus 8. This is equal to 0. Therefore, x is equal to 0, or 3x minus 8 equals 0. This will put 3x equals 8. We divide by 3, and then x will be equal to 8 over 3. So the question, you're being asked to find the x coordinate. So these are our x coordinate. X is equal to 0. X is equal to 8 over 3 for that line. Next question.
Determine the values of x if.
So now we are to find the values of x. The values of x
If negative 7 times gradient is greater than 0.
if negative 7 times the gradient is greater than negative 7 times the gradient is greater than 0. Right. We are multiplying by negative, which means when you multiply this by negative, the inequality sign change. Let's see. If you have negative 2 times x greater than 0, and you are to solve here, we divide by negative 2. Once dividing by negative here, the inequality sign changes. This will be like that. X will be less than 0, which means same thing here. When you divide by negative 7, let's see, dividing by negative 7 here, this will give us less than 0. We are to find the gradient. The values of x where the gradient is negative. Where the gradient is negative. So when you go down, the gradient is negative. Right? Our gradient is given by, we said it's 3 x squared minus, it's minus 8x minus 11 less than 0. Let's multiply by that. It's negative 7 times the gradient. Greater than 0. So obvious. Negative 7 is outside the brackets. You can divide by negative 7. The inequality sign will be affected. Let's go to our graph. When you look there, you just go to your turning points. X is, when you go to that direction, since our gradient is negative there, all these are negatives. Negative gradient. So, when you go to that direction up to this point, you do not pass here because the gradient will change to be positive. So it's from negative 1 to positive 11 over 3. Therefore, your answer will have only one x like that. It's less greater. The bigger number is 11 over 3. 11 over 3. The smaller number is negative 1. It's negative 1. So, without even factorizing there, just going back to your graph, you can find these values. It's where x less than 11 over 3 but greater than negative 1. You can factorize and solve there, but there is no need since you've got your graph. You just go and check your values there. Right here, we've got this function, the function of f, which is given by this equation. Y is equal to x cubed plus ax squared plus bx plus c. And then q is our turning point. We've got the x-intercept at point P and another one at point R, which is also a turning point. Right. And then the first question here, we are to find the values of A, B, and C. That's our first question. We are to find A, B, and C. A, B, and C on that equation. Right. Remember that we are being given these points. It's that stationary point and the x-intercept. For stationary point, we derive. So our given equation is y equals x cubed plus ax squared plus bx plus c. That's our given equation. And then we are being given a stationary point, so we have to derive this. We derive, this is 3x squared plus 2ax plus b. And then now, since this is the gradient at a stationary point, we let this to be 0. We let our derivative to be 0. To find the x value, we let the derivative to be 0. But then here we are being given the x value. We've got the x value, which is 0 there. Therefore, we substitute by the x value, which is 0, plus 2a times 0 plus b. Remember, we are equating our gradient to 0, which means it's 0 there, 0 also there. Therefore, the value of b will be equal to 0. We now have the value of b. Right, let's find the other remaining values, which is a and c. When you look up there at point Q, this is our y-intercept. It's our y-intercept. For y-intercept, we are to let x to be 0. So, for our y-intercept, we let x to be 0. Therefore, we are going to have y equals 0 plus a, our x is 0, plus 0 plus c. So y is equal to c. which means our C is the y-intercept. But then we are being given the y-intercept there, which is 4. Therefore, y is equal to 4, which represents C, which means our C is equal to 4. Our C is equal to 4. And then let us now find the value of B. We've got the x-intercept, we've got the stationary point, and then let's find the value of A. We've got the value of B and C, and then we are to find A. Right. For x-intercept, you let y to be 0. For x-intercept, you let y to be 0. So we are going to have x cubed plus a x squared plus bx plus c equals 0. We've got the x-intercept. We've got the x-intercept at point P. Therefore, we substitute by that value of x, which is negative 1 cube plus a times negative 1 squared plus, we found the value of b. We said the value of b is 0. b is 0. Therefore, this would be 0 times negative 1. And again, we've got the value of c, which is 4. This is equal to 0. Our unknown here is a. Here we are going to have minus 1 plus negative 1 squared. It's 1 times a. It's a. This is 0 plus 4 equals 0. Minus 1 plus 4. That will be plus 3 equals 0. Therefore, a will be equal to negative 3. A is equal to negative 3. We've got the value of b, which is that, and also now we are having our value of a, which is negative 3. Then let's write our equation. Y will be equal to x cubed, the value of a. The value of a is negative 3. Negative 3 times positive, then it's negative. This would be minus 3 x squared. The value of b is 0. b times x is 0. Therefore, we don't have that. We are going to have c. That is plus 4. X cubed minus 3x squared plus 4. That's our equation for the graph. The value of a is negative 3. The value of b is 0. And then the value of c is 4. Those are our values. And then let's move to the next question. Right, our next question, we are to find the coordinates of R. The coordinates of R. Right, R is a stationary point. R is the x-intercept. You choose any because this will be one the same thing. Right, let's use our equation to find the coordinates of R. Let us find the x value at the turning point. For the x value, remember you have to derive our equation. Our equation is y equals x cubed minus 3x squared plus 4. Right, let's find the coordinates of this point. The x coordinate we are going to derive. This will be 3x squared minus 2 times 3 is 6x. And then this is the gradient at that point. Therefore, we equate the gradient to 0. 3x squared minus 6x will be equal to 0. Let's divide by 3. It's x squared minus 2x equals 0. Let's factorize them there. It will be x into x minus 2 equals 0. It's x into x minus 2 equals 0. X will be equal to 0, or x is equal to 2. So these are the x values at the turning point. Let's check. X is 0 at point Q, as you can see, which means this positive 2 is for point R. Therefore, the coordinates of point R are 2 is to 0. It's the x-intercept at the same time it's a stationary point. And let's erase here. Right, the next question.
Use the sketch to write down your values.
We are now have to use our graph. We are to use our graph
To write down the values of for which
to write down the values of t.
for which the equation x squared x cubed plus ax squared plus bx plus c equal to d. We have always three real digits.
Let's say